Among our remarkable resource personnel, we have with us Dr. Panchami V. Dr. Panchami serves as the Head of Department of Cybersecurity IIIT Kottayam. She is the founder and faculty in charge of CyberLabs IIIT Kottayam. Her research interests include lightweight cryptography, authentication schemes, blockchain and cryptocurrency, post-quantum cryptography, and cryptanalysis using quantum algorithms. Dr. Panchami is a member of ACM, of the editorial boards of various international journals, and the technical program committees of several IEEE conferences. She serves as a reviewer and speaker for numerous reputed international conferences and journals. She is the principal investigator and a co-principal investigator of many funded projects. She also serves as the principal investigator for MEITY sponsored Quantum Computing Applications Lab and received the grant credits as well. She is the recipient of the NASCOM Award for the Lady Safety app and has received the Best Research Paper Award in various conferences. I now request Dr. Panchami to take the floor and upskill us on the topic, blockchain technologies and cryptocurrency.
Thank you, Shravasti, for the wonderful introduction. I'm Panchami. Now I'm going to discuss about the blockchain technology and cryptography, cryptocurrency. But when it is in the pen mode, it won't change. These are the contents that I am going to discuss: evolution of a blockchain, application, need of the blockchain, the very basics of blockchain technology with a demonstration. What are the different security features that are involved in the blockchain technology? Last, we will discuss about the cryptocurrency, Bitcoin, and the wallet. So I am planning to have a hands-on session on the MetaMask, which is the wallet, and the Remix IDE to implement the smart contract. So these are the contents that I am going to discuss in the coming hours. Yeah. So first of all, introduction to the blockchain technology. While considering the evolution of the blockchain, we can categorize into 4 stages: blockchain 1.0, 2.0, 3.0, and 4.0. So while we consider the blockchain 1.0, it is considered as the duration from 2008 to 2013. Okay. So you may heard about Satoshi Nakamoto. It's still an anonymous creator who introduced Bitcoin through a white paper in the year of 2018. Soon after 1 year, exactly speaking, Jan 2009, the first cryptocurrency called Bitcoin was introduced in the market by him or he. We don't know who is he's still, or that person is still anonymous. So when it comes to blockchain 1.0, it is considered as the currency and the payments. So the blockchain is completely constrained and the frame of the finance. Okay, so when we consider 1.0, it's all about finance and payments. When we switch to blockchain 2.0, there 3 milestones are happened. So when we consider the duration, it comes from 2013 to 2015. So in 2.0, there will be we can define 2.0 as is used to distinguish between the Bitcoin as an asset and blockchain as a programmed, distributed, trusted infrastructure or network. We can say that means, in simple words, I could say that when it comes to 2.0, there is a clear distinction between the asset and the blockchain. For example, say you may heard about Ethereum, right? So what is Ethereum? It's a blockchain. What is the asset or the cryptocurrency associated with Ethereum? We call it as Ether, right? Say when it comes to Bitcoin, okay, when it comes to Bitcoin, the network and the asset, the cryptocurrency is named under single name. We call it as Bitcoin itself. So on one hand, Bitcoin network, on the other hand, there is the asset called Bitcoin. So you may heard about the Polygon, right? Nowadays, it's very familiar among us. So Polygon is yet another blockchain, and the asset associated with the Polygon is Matic. Matic is the currency. Okay, so there is a clear, when it comes to 2.0, there is a clear association or a distinguishing between what is an asset and the Bitcoin blockchain network. So that's the first thing happened. In 2013, Walnut Buterin, okay, so he, through the white paper, he introduced Ethereum. So he find out that there are some restrictions in the Bitcoin network, right? Because Bitcoin is not at all developer friendly. So we need a flexible flexible blockchain in order to use for other purposes. So that's the basic concept where he introduced the Ethereum. Next milestone about 2.0 is that up to 1.0, blockchain is all about money and payments, right? But when it comes to 2.0, we can consider many assets. For example, you can consider certificate or trademarks, cars, energy, power, everything becomes an asset to the blockchain. So that means from the 2.0, we use blockchain to represent many assets, like certificates could be an asset, or cars, or energy, power, IoT, anything could be an asset towards the blockchain. Okay, so blockchain is started using for other purposes so that we can represent assets, different kinds of assets. The third milestone is more about introduction of smart contracts. So what is smart contracts? These are all small, simple programs which is stored in the blockchain. So as you know that the blockchains have different features, for example, immutability, security, that we are going to discuss. As these smart contracts are the part of the blockchain, it could inherit all the properties of the blockchain. So smart contracts are termed to be immutable. So what's the significance of the smart contract, right? So just assume with an example, if I am an entrepreneur, I am starting a company, it's a startup company, I want to develop a product. Okay, so if I want to develop the product, I need money, right? So I estimated that I need around 10 lakh rupees to come up with the product. Normal scenario is that, so who will fund for my project? It could be investors, right? In normal scenario, I will put forward my idea to some third party. We call it as intermediators or brokers. Then these brokers will communicate with the investors. So through these brokers, I could get the money. So what's the problem is that I have to give some amount of money to these brokers for this service that he is providing to me. Okay. And moreover, everything will be monitored under the control of these brokers. So through the introduction of smart contract, we could completely erase the third party called brokers or these intermediaries. How? As I am the creator of the smart contract, I need the money. I can design a program according to my logic, and I can put forward to the market or the internet. So the investors who are interested to invest in my project, they can come up, or they can invest, or they can transfer their money to the smart contract. So there is a first question is that whether smart contract could capable of holding the money. Yes, it could. It can capable of, even if it is a small piece of program, it could hold, or it can capable of holding money. So after holding the money, so yeah, as I said, this is small programs, right? Some logic is there. So first I wrote some logic in such a way that the minimum investment amount that could be received to the smart contract is 1 lakh rupees. So if any investor tried to send, say, 50,000 rupees, that the smart contract is not going to accept. Then the second thing is that the smart contract is self-executable when a condition is reached. In my example, say if the smart contract receives enough and more money, that is about 10 lakh rupees, that the whole 10 lakh will be automatically transferred to the creator's account. Who is the creator? I am the creator of the smart contract. Otherwise, if I cannot collect that much money within the time frame, this will be reverted back to all the investors' account. So that kind of transparency, traceability is there when it comes to smart contract. How it becomes traceable? This, for example, this investors invest their money through the smart contract. So smart contract is being the part of the blockchain, right? So they can view that, or they can trace that where their money is going, whether I am using this money for the development of that project, at what time I have used. Everything is very clear cut, or there is a transparency is there when we introduce such program called smart contract in our application. So there are 3 points. When it comes to 2.0, there will be a clear-cut distinguish between the blockchain network and the asset. We have started representing a plethora of assets like certificates or energy. Any could be connected to the blockchain. Then the introduction of the smart contract. When it comes to 3.0, they introduce the DApps. Okay, you may heard about the decentralized app, right? You are very familiar with the mobile apps. You are very familiar with the web apps. So what's the specialty? There will be a user interface, backend will be a server. Is it so? So similarly, server or a cloud or any sort of computing facility you could use. So when it comes to DApps, there as part of 3.0, it introduces DApps. We can simply say that the user interface plus the smart contract. User interface is there, smart contract is there. So you can create DApps in such a way that there will be a user interface. If you are good in web developing, you have a very wide scope in the development of DApps. That means you are good in designing, right? Maybe you are good in React and all. You can create the user interface for different blockchain applications. So when we connect the interface, user interface with the smart contract, and smart contracts are deployed in the blockchain, then we call it as the decentralized app. Okay, so decentralized app concept was introduced in blockchain 3.0, where the duration is claimed to be from 2016 to 2018. Soon after 2018 is comes under blockchain 4.0, where the people started using blockchain for different applications like industrial application, IoTs, or critical infrastructure like power grids. For power grids, for example, when the moment we connect the blockchain with the power grids, we can create a decentralized platform for gathering and distributing power or energy. So that's a specialty where so that we can, of course, with low cost, I have to emphasize that. So security, low cost, traceability, everything is achieved when we apply this blockchain technology for different applications. So that the industrial applications comes in blockchain 4.0. So this is the evolution of blockchain happening, and these are the different application of blockchain we can use in banking sector. Crowdfunding I have already explained, right? Because when we discuss about the smart contract, so that's a crowdfunding. Then banking sector, throughout my lecture I am explaining this wonderful technology through the particular or specific application called banking. Next is we can use for IoT. How we can integrate IoT with the blockchain? Because normally in an IoT, we have a sensor node, right? There will be a sensor. It could be a microcontroller or a processor. Then there will be a Wi-Fi module. Then this Wi-Fi module will be connected to a gateway, then gateway to cloud or IoT server or whatever it is. So this is the normal IoT architecture that we are following. So when the moment we connect IoT with the blockchain, what happens is that we have the IoT nodes, okay, which sends the data. Through the IoT nodes, we can send the data. So the backend side will be the blockchain. So we can enable very traceability. We can enable traceability, then security for this data while coming from the IoT devices. As I said, power grids, critical infrastructure also we can enable, or we can connect it with the blockchain, because gathering of the data and the distribution of the energy with low cost can be enabled or achieved through the technology called blockchain. So these are the various applications when it comes to blockchain. So I'm explaining this blockchain technology with a particular application called finance or the banking. So firstly, let us discuss what are the different problems that we face in a banking sector. So before going to that, this figure on one side, there is a traditional approach where you can see a centralized authority who is that centralized authority could validate the transactions, right? When we do any sort of transaction, that centralized authority is responsible for validating. Normally, it's a financial institution, we call it as banks, right? On the other hand, and this centralized authority is responsible for storing the data, processing the data, managing backups, everything they are doing with the centralized authority. If something happens to that centralized authority, what will happen? We will lose our data. As a result, we will lose our money, right? So on the other hand, there is the blockchain approach where you can see that there is no central party to validate the transaction. There comes two questions. Who is responsible for validating the transaction? The second question is that where we will store the data. So who will responsible? Here you can see there are 4 peers or nodes. Say one is Alice, one is Catherine, Daniel, and Bob. Okay. So four peers, and these 4 peers are responsible for validating the transaction, not a single peer or a central authority. And where we are storing this data, all the peers will store their own data as well as all others' data. Okay, so that means I am storing my own data as well as other data as well. Of course, there are different demerits for this. What will be the demerit here? Yeah, there is multiple copies as, yeah, because we in a distributed thing, we are claiming it as the advantage. But what could be the disadvantage? In banking, there will be privacy, right? Because what others are doing, what sort of transaction, how much money they are holding, we cannot know that. So privacy is preserved in the traditional approach. And moreover, when we take care of a UPI, Google Pay, we are all familiar with that. So per second, we are doing millions and billions of transactions per second. Okay, TPS rate is very high when it comes to transaction of traditional approach. That means the banking. But when it comes to blockchain, especially Bitcoin, per second, we can do only 15 transactions. You are very familiar with, or you may heard about Ethereum, right? Ethereum 1.0 is there. In the year of 2022, Ethereum 2.0 was introduced. So Ethereum 1.0, 15 transactions per second. When it comes to 2.0, it can scale up to 20,000 transactions to 1 lakh transaction. But in our average scenario, 75 transactions could be possible per second. So we just reached only 75 transactions per second. But when we cannot compare with a normal UPI transaction with a blockchain transaction. So scalability is a problem as well as privacy is a problem. So there are a plethora of scalable solutions are there, like as a result, Polygon evolved. Okay. And for the privacy matters, yes, we can develop privacy preserving cryptocurrency, privacy preserving smart contract as well. How? With the wonderful idea of zero knowledge proofs. Have you heard about that? Zero knowledge proof. If you can, while implementing this zero knowledge proofs, you can come up with privacy preserving dApps. Okay, so coming back to our agenda. So this is our scenario. Let's look what are the problems that we are facing when it comes to banking sector. The first thing is that, say, one is Alice and another is Bob. Okay, Alice want to transfer some amount of money to Bob, but Alice is residing in one part of the world. Bob is in another part. Just assume that Alice in India and Bob is in America. Alice is holding Indian rupee and Bob is holding dollars. Okay, so their sort of conversion should be there. As a result, they want to transfer money from one person to another. Here, in between these two parties, who is there? Central authority is there. We call it as bank. They will enable some percentage of money as a transaction fee. So there will be a high transaction fee that we have to pay for a third party to do the service. So high transaction fee. Next is if I want to share some amount of money to any part of the country, then minimum we have to, if it is a wired connection and all, I have to wait for minimum 24 hours. So there will be a time consumption, high time consuming when we try to when we try to send data from one person to another who is residing in different parts of the world. So time consumption is there. Double spending is the scenario in which if you try to transfer a data or if you try to transfer some amount of money to two different parties, at the same time, that scenario we call it as the double spending. Double spending could be intentional one or unintentional one. When it comes to intentional one, it could be hackers or crackers doing that process. And unintentional one means we are all may use or very familiar with that. If you could double tap the button twice, then it leads to the unintentional process of double spending. That means, once again, double spending is the process in which if a person tried to send the money to two different person at the same time. Okay, so there my point is that in the traditional approach, double spending scenario still occurs. Network frauds, even if any technology came, network frauds are there because network frauds are very intelligent people. We are all facing, we are receiving mails, calls and all in order to share our credentials. But if they are very smarter, as you know that this is the centralized approach, if they are very interested to a single point of access. So if we get the access towards the central party, that means the database stored in the bank, they can modify the data. So instead of say 10 zeros, if we delete 5 zeros, what happens? That client will lose the money, right? So it will affect the credibility of the data, because this is one of the disadvantage of the centralized approach. Next is about the poor data recovery, as this is the centralized approach. That means a single server or is storing your data, and say some sort of catastrophic things happen. As a result, of course, bank invest a huge amount of money, billions and millions of money on security and the backups. Okay, so here the scenario, poor data recovery scenario is that if I want to get my data, say 10 years back data, I want to write a request to the bank and I have to wait for months, days and weeks and months to get my data. What an irony it is. It's our own data and we are asking to another person that I need my data, right? So these are the problems that we are facing for the banking sector, and these problems are solved using this blockchain technology. The first thing is that we are even if blockchain technology is there, we are doing business. So we cannot say that there is no transaction fee, but minimal transaction fee. So there will be a low transaction fee when it comes to blockchain services or the services which is underlined by the blockchain technology. Time consuming, wherever you are residing in this world, the transaction will be happening within 10 minutes on an average of 10 to 15 minutes. Double spending, the double spending scenario, the feasibility or the probability of having the double spending scenario is very negligible in terms of blockchain approach. Frauds are there, of course, but even if the frauds, who are storing the data, we are storing our own data as well as we are storing others' data, right? So there is no issue of data recovery because we ourselves store our data as well as others' data. Network frauds, for example, out of these peers, someone is malicious. Just consider someone is malicious. Then if he tried to tamper the data, because he is storing the data, right? If he tried to tamper the data, not only that particular block, the entire block becomes invalid. So that's the simple reason, because, and we are claiming that the data which is being stored in the blockchain is immutable, but there are multiple layers. I will explain in later. So maybe you got an overview, right? And these problems are solved with the help of blockchain technology. Then, of course, going to the blockchain technology, we can claim it as a cryptographically secure distributed open ledger. Before going to that, I want to have a very clear distinguish between what is blockchain and Bitcoin. Bitcoin is what? Bitcoin is what? It's a digital currency. Okay. And how you explain blockchain? So if you want to transfer the digital currency from one person to another with minimal transaction fee, we need a technology. It involves security, it involves distributed computing, it involves networks. So we need a technology to transfer the money from one person to another with minimal transaction fee. That technology, we call it as blockchain. So hence, we can say that blockchain is not Bitcoin. Blockchain is not just cryptocurrency. But apart from that, we can use blockchain for multiple applications. Yeah. So coming back to the definition of blockchain, very simple definition is all about it is a cryptographically secure distributed open ledger. The transactions are immutable. So first we have an idea about what is distributed open ledger, right? So we have to know about distributed open ledger. So there are 4 parties. We call it as Alice, Bob, Catherine, and Daniel. Say Alice is holding some 10 Bitcoin. Okay. All the transactions that is done in this particular network is stored as a chain of transaction and it is stored in the ledger. So ledger means it's a chain of transaction. How much Alice is holding, that is known to all the party in the network and it will be recorded as part of the ledger. That's the first point. Second is, so first we have to discuss about the open ledger, which is everything is open to all the peers who is in the network. Second point is that if Alice want to transfer some 5 Bitcoin to Bob, okay. So here first, who will validate this transaction? All the peers in the network will validate the transaction. How it will be validated? If Alice is holding 10 Bitcoin, out of 10 Bitcoin, she can easily spend 5 Bitcoin out of that, right? So in that, using that logic, it will be the part of the ledger. Okay. So Alice to Bob, how many Bitcoin? 5 Bitcoin. Next is Bob, 3 Bitcoin is being sent. Okay. Is this particular transaction will be the part of the ledger? Yes, because out of 5, he can easily spend 3. So it is also being the part of the ledger. So Bob to Catherine, 3 Bitcoin. Okay. So if Catherine try to send 10 Bitcoin, is it possible whether this transaction become the part of the ledger? No, because Catherine, she don't have that much money to spend. So that all the peers never agree upon that particular transaction, as it is not at all a valid transaction. It never going to be the part of the ledger. So my point is that ledger is all about the chain of transaction. What do you mean by open ledger? Open ledger means how much money that each party is holding, what are the transactions done by every party, that is open and available to every peers in the network. So hope you understand what is open ledger. Is it so? Yeah. Next is, can I call this is a distributed open ledger? Can I call this now? This is a distributed open ledger? No, this is not a distributed open ledger. It's still a centralized one. If I want to call this as a distributed open ledger, a copy of this ledger should be saved or stored as each peer side. Okay. Now we can call it as it's a distributed open ledger. When it comes to distributed open ledger, that means every peer in the network is holding not only their own data, but others' data as well. So here there will be a problem. Can you find out any problem over here? Yeah. So the problem is synchronization problem. That means the network want to ensure that the same copy of the ledger is being stored at each peer's end. How you overcome this synchronization problem? Through the concept of mining and flooding. Okay, so mining means, I will just have an introduction about the mining. Mining means out of these peers, there are some special nodes. Okay, for example, here there are 4 nodes. Out of these nodes, this is a normal node. This is also normal node. I am claiming this is the minor 1 and this is the minor 2. So what's the eligibility to become a miner? We have to possess, or the miner has to possess, huge computing power with them. For example, if I am trying to be a miner for a Bitcoin network with this laptop, it's not going to be successful because I can install the software. I can go ahead with that. The moment I open it and started mining, completely become stuck. So miners want to come up with good computing machines. Okay, that's the only point when comes to the mining. So logic is completely brute force attack, or brute, not attack actually, it's the trial and error method that we will discuss I will discuss later. So there are, in this network, there are some special node called miners. Apart from that, normal nodes also there. Here A and B are the normal node and C and D are the miners. So what this miner will do? Miner, for example, if say this is a block, this is another block, this is another block, this is an existing chain. If a new block has to get added to this chain, who is responsible? The first question is that who is responsible for adding the block to the chain? And next is, of course, if you want to add this block, there are some transactions over here. So we will want to validate the whole block. So who will validate the block as well as who will add the block? That's the responsibility of miners. So miners will validate each block. So block consists of transactions, not only single transaction, multiple transactions, maximum up to 15 transactions when it comes to Bitcoin network. Yeah, so the miners are responsible for adding or validating the new block, as well as once it is validated, the new block is updated to the existing block by whom? Miners. So for example, if a transaction, the first transaction came over like Alice to Bob 5 Bitcoin, then what happens is that miner has to do some sort of work. We call it as proof of work. I will explain that. Yeah, so the miner want to first confirm that whether this transaction is a valid one or not. Once it is validated, it will be the part of a block. So the whole block has to be validated by a particular miner. Once the block is validated, this miner will, or M1 or M2, it depends, want to update the block with the existing chain. Now what happens? This becomes an updated chain. So this miner has a newly updated chain. He added an extra block over here, right? What happens is this miner want to flood this transaction, newly updated chain to the network so that the whole peer will get an updated chain. So this is the way in which this synchronization problem is being solved. Okay, so who will, through the synchronization problem will be solved with the concept of mining as well as flooding. So mining means who will do the mining? The miners will do, who are the special nodes, who are capable of validating the new block, as well as once it is validated, it will be the part of the existing chain. Once it is the whole chain is being modified, they have to flood in the network so that the whole peer will get the updated chain. Okay. Here I want to, one more point I want to emphasize here. We said that double spending is not at all possible in the blockchain technology, right? Double spending is not at all possible. Say, for example, Alice is holding 10 Bitcoin. Okay, so Alice is holding, everybody know that Alice is holding 10 Bitcoin. Then at the same time, Alice initiate 2 transactions, Bob to Daniel, Alice to Bob 10 Bitcoin, and Alice to Daniel 10 Bitcoin. Now any one of these transaction becomes a double spender transaction. So what happens is that if a 2 transaction is flooded across this network, all the peers can validate this transaction. Only any one of this transaction becomes the part of the ledger. The other is treated as the double spender transaction. How? Because everyone can know that how much Alice is holding, 10. So that they can easily identify whether that transaction is a double spender transaction or not. So including minus all the normal nodes, whether it is a normal node or a minor, first they will check for whether a transaction is a double spender transaction or not. Okay, this is the way in which the double spending is being prohibited in the blockchain technology or blockchain network. Next is we are moving more details about the blockchain. So we can say that blockchain is a distributed public database. Now it's clear, right? Database means what? It will store data. What kind of data here we are storing? Transaction data, because we are dealing it with the finance application, right? So it's a distributed public database. It's clear, right? Distributed public database, and the data are being stored in blocks. So blocks, here you can see we are calling it as blockchain, right? These are all blocks. These are all blocks, and it is connected with chain. Is there any chain available over here? No, some concept we have to incorporate, right? That we will discuss. So there is a blocks involved, and it is each blocks are connected with chain. So that there comes the term called blockchain. So what each block will consist of? Block will consist of hash of the previous block, right? From the first session onwards, you are hearing about hashes, right? So hash of the previous block, transaction data, nouns, hash. So nouns means it's a random number which is used to generate the block hash. Transaction data, it's not only a single transaction, a block can incorporate multiple transactions. So this is the main data which composed of, or the block is composed of this much data. Next, coming to what we have explained, a block consists of what are the things? A previous hash, a block hash, then nouns, transaction data, right? Now we will check for the working. The first block in the blockchain, we call it as the Genesis block. According to this Genesis block, there is no predecessors, or there is no previous block. So that's the reason why the previous hash is all zeros. It's nothing like 4 zeros. Here in Bitcoin network, we are using SHA-256. That means either it will give you an output of 256 bit, or normally we are representing it as 32 word. That means the hashes are represented as 32 words. 32 zeros will be there. Next is, as I said, when the Bitcoin network, there is a SHA-256 algorithm. For the SHA-256 algorithm, the output we call it as the block hash. So block hash is used to represent each block uniquely. So from the first session onwards, you can represent anything uniquely with the help of the concept of hashing. So here we have multiple applications for hashing. One of the application is that we can represent the blocks uniquely, okay, using the hashing concept. So what's the input is that, yeah, so what are the inputs? The one input is transaction data, because from Alice to Bob, 10 Bitcoins, or multiple transaction, not single transaction. I'm repeating, multiple transaction will be the part of a single block. Transaction data, then timestamp you may heard, right? At what time it is being generated, timestamp. Then previous hash. Here, as this is the Genesis block, there is no previous hash, but the previous hash values are all zeros. So previous hash. After that, nouns. It's very important. Please note it down. Nouns is a random number. Okay. And because of this random number, we are generating unique values for each block. So while inputting all these values, we will get an output from the hash value. So that hash value will be the block hash which act as a unique identifier for each block. So let me ask you, then what about block 2? So block 2, how you going to generate the block hash of block 2? So again, there will be a SHA-256 function. What are the inputs? What will be the inputs? Yeah, transaction data, previous hash. Can you tell me the previous hash? 1Z8F. Yeah, then nouns value. So once we use a particular nouns value, we do not repeat the same value. It's a random number. So nouns value, then timestamp, so that we will generate that hash of the second block. Again, I said like there is the concept of chain. How we come up with the concept of chain? It's nothing like there is no chains available in between the blocks because everything is logical. The chain is because of this previous hash. The hash of the block 1 will be given as an input to generate the block hash of B2, so that this hash, right, will be acting as the chain. So it is interconnected. So that's the way in which we are interconnecting blocks through the concept of previous hash. Okay, so what about the block 3? So block 3, of course, we input the transaction data according to block 3. 6BQ1 will be the block hash, then the nouns value with different value. Then we are giving to the SHA-256, we will generate the block hash of block 3. Okay, so next is we are claiming that it is immutable, right? The data inside this data, the blocks are immutable. How? The first reason is that because of this hashing, the moment you tamper the data, okay, if you change any data, what happens? Hash will changes, the block hash will change. Okay, if you compare this block hash with the previous hash that is stored by block 2, whether it's going to match? No. As a result, not only this block, the entire block becomes invalid. Okay, but it's not sufficient to claim that we cannot tamper the data in the blocks, because we have very computing, so we have very fast computers, high performance computers are there who could generate hundreds and millions or hundreds and thousands of hashes per second. So if you tamper a block, it is easy to find the hash value of a single block. So we need some extra techniques to make it immutable. So there are 3 layers. We can claim it as the data which is stored in the blockchain is immutable. The first thing is hashing. The second thing, you may heard about the proof of work, which is the consensus algorithm. The third point, which is the 51% rule, as well as the distributed nature. So because of these 3, basically hash, second proof of work, the third distributed, plus this 51% rule. So because of these 3 points, we are claiming that it is infeasible to tamper the data which is being stored in the blockchain. So I will explain it I will show a demonstration what I have discussed so far. Yeah. So this is a SHA-256 one. Say I am inputting high. Okay, high. So every time if I input, you could see that these hashes are changing, right? Okay. And I will explain about the properties of hashes. Whatever, how much data I am inputting, okay, whether this size of the hash changes? No. So the first property is that you can input variable size of message, but the output will always be fixed. Okay, here how many characters over here? There will be 32 characters, because here we are using SHA-256. Either you can get output as bits, or you can take according to your logic. You can, normally we are taking it's the words. So there will be 32 words, whatever your message is. So variable length of message, you will get fixed size output. Next is here the property of the hash which is used by the blockchain is that according to this is the hash of the whole message, right? This is the hash of the whole message. This hash will act as a unique identifier for your message. You can uniquely identify your message with the help of hash. There are multiple properties, like the moment you input, it should be efficient. That means it should be fast. The moment you input the message, it should be fast to find the hash, the corresponding hash. Next is collision resistant. Collision resistant means there won't so it won't be available. Two messages won't give you the same hash value. There are strong collision resistance and weak collision resistance. However, two messages, if you give two different messages, it never ever going to be the same hash. So there are few properties associated with a hash function. If the properties are then the main property is the one-way property. Okay, so you may heard about, you are very familiar with the set theory, right? And so from for example, hashing is a one-way function. From this message we can reach to hash, and it is infeasible to compute this message when a hash is given. It's a one-way property. But if you take care of encryption algorithm, it is a two-way function. From encryption, from the plain text to ciphertext, there will be an inverse function called decryption function. So using this inverse function, we can reach to the plain text. So the encryption is a two-way function, but the hashing is a one-way function, because the moment we get the hashes, it is infeasible to compute what the message is. At the same time, it will act as a unique identifier for your message. Okay, so this is all about hash, and it is being used in the block. So a block consists of block number. Of course, there will be a nonce. As I said, nonce is a value. It's a random number. Once it is used, we never use this number once again. And here, another point I want to emphasize is, you can see this is the block hash. Can you see the block hash? Is it so? Can you compare this block hash with a simple hash? Okay. What's the difference between a block hash and a message hash? Can you find any difference? There are some zeros, right? There are some zeros. So we have explained already that a miners want to validate the transaction. What the miners will do, right? Miners will do some sort of activity. We call it as the mining process. And what's the main activity of the miner, or what's the main function they have to do? They have to validate the block. A newly block, if a new block is coming, they have to validate the block. How they are going to validate? Through a process called consensus algorithm. The particular consensus algorithm, it is being used in the Bitcoin network, is proof of work. You are aware about Ethereum, right? Ethereum 1.0 uses proof of work, but when it comes to Ethereum 2.0, it uses proof of stake. Proof of work, I will explain. Proof of work in the sense, the miner want to find this nonce value, but a given target is given. Target in the sense, target is something like some zeros are there in front of hash value. So the number of zeros increases, the difficulty to find the nonce value is also increases. Okay, so what the miners, the miners want to undergo through the consensus called proof of work, so that they have to show to the network that their intentions are not malicious. Okay, their intention, they have to show the network they have done some work. So what is the work they have done? They have to find the nonce value. A target value will be given. Target value, something looks like some zeros are in front of this hash value. They have to input this nonce value, block number, the timestamp, the previous hash to a SHA-256 function, so that an output will be generated. That output will be compared with the target value. If it is less than or equal to the target value, we can claim that the miners won the puzzle. So this is acting as a cryptographic puzzle. So proof of work mechanism is a cryptographic puzzle. So what that miners want to find out? They want to find out the particular nouns. Okay. When the moment they find out the particular nouns of the block, we can claim that the block is being mined. A new block is being mined. So if I tamper the data over here, just an interface, you can see it is a tampered block. If we want to convert this tampered block into a normal block or a mined block, then the miners have to do the mining process. Okay, so the backend side, what they are doing, they have to find a new nouns and there will be a target. So who is providing the target? The network will fix the target. The target is in such a way that it's not too easy or too hard to find out. The network will fix that the finding out of this noun will be happening within 10 minutes. So that's the reason why every transaction, a new block will be mined on every 10 minutes. Okay. So now you can see that I have mined this tampered block and now I have received a new nouns. Okay, I will explain this particular concept once again when it comes to the PPT. Okay, so this is the block. When it comes to blockchain, this is chain. Okay. If I try to tamper the data, not only that particular block, the whole block becomes invalid. As I said, immutability is not possible, or immutability is achieved using the blockchain technology, because the first point is that hashes. If you try to tamper the block, then the hash will change. As a result, the whole remaining chain becomes invalid. But it is not sufficient to make it tamper proof. We need some extra mechanisms called proof of work. Proof of work I have already explained. So proof of work is a mechanism to restrict the generation of the blocks. So it will restrict the generation of the block in such a way that every 10 minutes only one block is being generated and it will be the part of the chain. Okay. So what's the reason behind the tampering, or how the proof of work mechanism will enhance or how it contribute to the immutability means, as I said, if you want to, we have tampered the whole chain, right? We have tampered the whole chain. If I want to make it as a valid block, then I have to do the proof of work mechanism of this particular block, and it will take 10 minutes. If I want to do the proof of work mechanism of all the remaining blocks, it may take hours. Is it so? Minimum 1 hour it will take. But if it should be an acceptable one, the whole block has to be mined within 10 blocks. It is infeasible. So it is infeasible to compute the proof of work mechanism of whole block within 10 minutes. And that's the second reason why we are claiming it as it is immutable. And the third reason why the data in the blockchain is immutable, because of distributed concept and the 51% rule. Distributed concept means there are the same copy of the blockchain is being stored by the peers. If I try to tamper over here, what happens? The entire chain becomes invalid and it is completely different from the blockchain which is held by other peers. If I am a malicious and I am holding enough and more computing power, or a supercomputer, or nowadays quantum computers are there, then I can do parallel processing. Then somehow within 10 minutes doing the parallel processing, I came up with the solution of not only the single block, the complete block. Okay. Because we are assuming, as security personnel, we are assuming that the adversary has enormous power, unlimited power. So in that way, I can come up with, somehow I can come up with the, now it becomes a valid chain, right? Is it so? It becomes a valid chain. But when you compare the copy of the chain that you are storing with others, B and C is storing the same copy, but you are storing or you are holding an entire different copy of the chain. Okay. there comes the 51% rule. If more than 51% of the peer agree upon your newly modified chain, then only it will be a valid chain. Otherwise, whatever the effort that you have done, whatever the time you have invested, your money, your computing power to do the whole process, it's going to be waste. So in a nutshell, I could say that how much effort that you are giving towards tampering this data, ultimately at the end it is going to be not a successful one. So it is infeasible to tamper the data. So this is the reason why it is infeasible to tamper the data which is being stored in the blockchain. Hope you understand, right? Okay, so there are certain features of the blockchain which make it cryptographically secure. One is SHA. We have already explained. These are the properties while demonstration I have explained. Another property I just want to emphasize is the here while looking at this one, Fox is the input to a hash function. The second and third, I am interested in the second and third input. Can you find any difference in these inputs? Yeah, so instead of V, it's changed to U, right? A single character is being changed. Is there any similarity in the outputs? No, there is no similarity in the outputs, even if the message is very similar. Is it so? This property is known as avalanche effect. This property is known as avalanche effect. How we explain avalanche effect? If we flip a single bit in the input, more than 50% of the output bits are being flipped. And this property, this avalanche property should be preserved in encryption algorithms, of course, most of the cryptographic algorithms. Yes. Yes. Can you address last? Yeah, I can. I could address. Okay, at the end I will address it. This I will explain while I am coming across with the Bitcoin, because it's completely cryptography. When it comes to application, I will explain this scenario. Okay. So proof of work is the mechanism to it is the consensus algorithm or consensus mechanism to validate the block, and it is done by the miners. The proof of work and because of this proof of work, we can also achieve immutability. But it has its own disadvantage because it's power consuming. Monopoly attack is also there. So because of those sort of disadvantages, Ethereum 2.0 is shifted from proof of work to proof of stake. Stake means how much you hold, that much you can be the part of the mining process. But proof of work mechanism is underlying in only one scenario. If you have enough and more resources with you, you can be a miner. That's all. That's the only concept. I will explain the proof of work mechanism. Here you can see this is the target, okay? Proof of work mechanism in simple. Yeah. See, there is a hash function over here, right? I'll just a hash SHA-256. So this is the proof of work flowchart of the proof of work mechanism, and it is done by who? Miners. Okay, so SHA-256, it is a Bitcoin network. According to the miner will input the first nouns, of course, transaction data, previous hash, then what else? Timestamp, so that it will generate a hash number. So there will be a target value. Target value something looks like 000, say A16. Okay, there will be 32 characters. So who will fix the target value? The network, it will fix the target value. Based on this 0, we say that it is the difficulty level. Okay, when the number of zeros increases, finding the particular nouns of a block is also increases. Then the proof of work mechanism is that while giving, the miners will select a particular random number N1, and it is given to SHA-256 along with the transaction data, and it is giving the output will be a hash code, and this hash code will be compared with the target value. If it is less than or equal to the target value, then we will say that the miners won the cryptographic puzzle. If they won the cryptographic puzzle in Bitcoin network, they will get 6.25 Bitcoin. Nowadays, Bitcoin is in and around 26 lakhs or something, one Bitcoin. Okay, so just assume that like in and around 1 crore they will get. Okay, what's the strategy they are following? The first thing is that they need enough and more computing power with you. The strategy is that they just want to play a trial and error method. So if it is a false one, if the condition is false, they have to do, it will be in a loop. They have to try for the next nouns. Again, they will do whether the condition is satisfying or not. And on an average scenario, the loop will continue till 10 minutes, because within 10 minutes, anybody in this world may come up with a solution. So the difficulty level is set in such a way that it is not too complex or too simple, but we have to, or the miners want to find the solution within the 10 minutes. So some sort of difficulty is there. So how much difficult? It's not easy task, because the miners want to try how much? 1.5 to 15 quadrillion nouns. Within 10 minutes, they have to try for this much nouns in order to find the nouns value. So this is the proof of work mechanism. Is it okay? And it is still there in the Bitcoin network, but in Ethereum 2.0, 1.0 use this proof of work mechanism. When it comes to 2.0, proof of stake mechanism is being used. And the whole procedure, we call it as the mining. And you know that when Satoshi Nakamoto introduced this Bitcoin, that he first launched 50 Bitcoin to the market. When he launched 50 Bitcoin in 2009, the value is $0. Okay, when it reaches 2011, it reached one Bitcoin cost around $5. But when it comes to 2021, the market value becomes the peak, where one Bitcoin cost around 56 lakhs. Now, I think the Bitcoin is 26 or 24, in between 20 lakhs, one Bitcoin. So that's the reason why people are interested in investing in the cryptocurrency, but it is fluctuating based on the market. And yeah, so here there is a halving technique where first he introduced 50. The second, after 4 years, the 50 will be reduced to 25. Okay. Next 4 years again, and now we are reaching. Now, if you are doing the mining process, we will get around 6.25 Bitcoin. And when it comes to 2024, it's again going to half, so that if miner do the mining process, we will get 3.125 Bitcoin. So it is assumed that in and around 2140, when the year 2140, there won't be any monitorial benefit for the miners when they come across through the mining. So it's saying that it based on the market, because at that particular time, the Bitcoin network becomes a stable one. At that particular point, we don't want to market saying that, hey, we give you this much money, please get into this network. So it becomes a stable one at that particular point, so that there won't be any monitorial benefits when it comes to 2140, in the year of 2140. Okay, when the miner do mining process at that particular era, he won't get any kind of monitorial benefit, because every 4 years it will be halved. Yeah, so in a nutshell, I could say the whole transaction procedure in the Bitcoin network. Say if Alice want to transfer some 10 Bitcoin, it's a transaction, right? So Alice will flood the transaction across the network. So there are some nodes called miners. They will collect the transaction. So once some n number of transactions are there, they will convert it into a block. So this block consists of, it is not a not validated block. So next part is that we want to validate this particular block. So for that purpose, this block, there are some special nodes in the network, call it as miners, who will do the validation of the block. Once it is through the process of proof of work mechanism, once it is validated, they will get, that means validated means they will find the particular nonce value. If they get the particular nonce value, they will get a monitorial benefit of 6.25. Then they can add the new block to the existing chain. Once it is a newly updated chain from the miner side, the miner want to flood the newly updated chain to the network so that we can overcome the synchronization problem. As a result, Bob will receive how many Bitcoin? 10 Bitcoin. The whole process will take place within an average time of 10 to 15 minutes. Okay. So when it comes to Bitcoin, Bitcoin is a digital currency. There is no central authority. It's like a peer-to-peer network. And the payments in the Bitcoin is done in such a way that I just want to give you, say this is a peer-to-peer network. Okay. Say suppose this is Alice. And we don't know whether it is Alice or not. That I will discuss with you. And this is Bob and Catherine and Daniel. So Alice want to send, say this is Catherine. Okay, this is Catherine. And Alice want to send some 10 Bitcoins to Catherine. So what happens is that Alice will initiate the transaction. How you represent the transaction? Alice to Catherine, 10 Bitcoins. And it is flooded across the network. Flooded means it will be distributed across the network so that the new transaction will be received by B, then this node, and this node. Okay. So while Bob receives this transaction, along with the, in practical scenario, I'm explaining, along with the transaction, Alice will send her public key plus the digital signature of the transaction. So three things are actually flooded in the network. What are the things? The transaction, public key of Alice, then the digital signature. So there is a question that how the digital signature of the transaction is being generated. That's the first question. Next is, upon receiving the transaction, right? Upon receiving the transaction, public key and the digital signature, what each node will do. So whether this Bob will be a normal node or a miner, irrespective of what kind of node it is, they will do the origin of, they will validate the origin of this transaction, whether this is actually originated from Alice itself. Okay. And it is done by the cryptographic concept. So this is actually the transaction. The first question is that how Alice will generate the digital signature of the transaction. So this will be the transaction. It will be given to a SHA-256 function. It is Bitcoin I am explaining, so that a hash code is generated. So suppose this is Alice, right? Alice do have two kinds of key, public key of Alice and the private key of Alice. Similarly, Bob is also having public key of Bob and private key of Bob. Okay, so what Alice will do is that Alice first, this transaction will given to the SHA, then a SHA code is being generated. This SHA code is given to an encryption function. It's an asymmetric encryption because this encryption is done with Alice private key. So for this encryption, there are two inputs. What are the input? One is the SHA code, okay, of the transaction. Another is the private key of Alice, so that the digital signature of this transaction is being generated. So the transaction plus public key. The private key is only known to ourselves. Okay, so the private key of Alice is only known to Alice. So the transaction plus public key plus this generated digital signature is broadcasted or flooded across the network. Upon receiving by Bob or any intermediary party, what they will do is that out of this transaction, okay, that is this data is given to a SHA, then a hash function is being generated. On other hand, this digital signature, right? This digital signature is decrypted with an inverse function, and this public key is used as an another input. So public key for the decryption function, public key of Alice plus the digital signature will act as the input so that it will get the hash. So if these hashes are matching, then Bob can ensure that this particular transaction is actually originated from Alice itself. Is it clear? And this is the way in which payment is done in the Bitcoin network. And we don't want to, it is automatically there by using the concept of Bitcoin scripts. Scripts are some other programming language. It's just like HTML tag. It's like a stack-based language. So that using that concept, we each and every party or every peers in the network will validate the transaction whether it is origin from Alice or not. Okay. Next is this is the point where Bitcoin or most of the cryptocurrencies are preserving anonymity, because we don't know whether it is Alice, Bob, or Catherine. The peers doesn't know. Okay. Why? Because I will explain it with. We'll do the hands-on. I will explain this Bitcoin anonymity with the hands-on. Okay. I have shared a notepad like this. Have you ever noticed? Okay. How many of you have installed the MetaMask? Okay. So I have already explained that Alice or any party who joins the network is holding two keys, right? What are the two keys? Private key and the public key. The private key is only known to ourselves, but the public key will be known to others as well. And so where these public key and private keys are being stored, there's a question, right? It is being stored in the wallets. Okay. So if you want to join the network, first you have to hold a wallet. It could be a hardware wallet. It could be a software wallet. This is a web-based wallet, which is MetaMask. Okay. It is a web-based wallet. And using this web-based wallet, we can create multiple accounts. So here you can see that I have created enormous accounts, more than 2 accounts or multiple accounts using this wallet. So consider, just take care of a single account 1. Okay. Account 1. Account 1. For each account, there will be a public key and a private key. So this I just copied. My public key of account 1, say account 1, and the public key is this one. Okay. And there is an private key associated with this one. How you can see the private key? There is a 3 dot over here, right? Account details. Go to account details. Then export the private key. Here you have to enter your password. So you can see the private key associated with this account. Can you see? Yeah. Then there will be a question that what will be the address of this particular account, right? Your public key acts as the address of the account. Can we identify whether this belongs to me? Can you identify this account belongs to me while getting this public key? No, this is somewhat some random alphanumeric value, right? So that's the reason why we claim it as anonymity is preserved in Bitcoin or any cryptocurrency. So, and for example, frauds or crackers, they will crack some sort of network and they will ask for the ransom, right? And if they want to provide the service, we have to give them some money. Okay, ransom they may ask. So they will send only their public key. While getting the public key, can we identify who is the hacker or the cracker? No. So that's the reason why we are claiming that anonymity is preserved in Bitcoin or most of the cryptocurrencies. And I don't want to go ahead and showing for the yet another account. Is it so? So if you take care of the second account, this will act as your public key, right? This will act as the public key. And so there will be an entirely different public key, private key pairs, right? So in a nutshell, I could say that for a single, while using a single wallet, you can create multiple accounts. Okay, that is clear, right? Anonymity, it's clear. Next is here, please listen. Here, there are n number of blockchains are here. This is Ethereum mainnet. That means which we will really deals with the real money. So if I select over here, do I am holding any ethers? No. That means if the moment you represent any numerical value over here, that means that much asset I am holding. It's a real asset, real money. But for the developers, Ethereum is very developer friendly and flexible. So that's the reason why Ethereum provides two test network. If you're a developer, you can start with the test network. One is Gorilla and Sepolia. And these are the test network based on Ethereum 2.0. Okay, now it is only there is only two test network as part of Ethereum 2.0. It is Gorilla and Spolia. But later, when it comes to 1.0, Ethereum 1.0, there are multiple test network like Coven, Ropsten. So these are the test network which is available till November 2022. Now it's not there. Okay. So these are the test network. Well, if I select the test network, yeah, I'm holding amount, right? Then next is, if you want to integrate a new blockchain with your wallet, what's the procedure? Okay, n number of blockchains, n number of Bitcoin or cryptocurrencies are available in the market. If you want to integrate, this is your wallet. And if you want to integrate or add a new blockchain to your wallet, what's the procedure? So for example, let's take Polygon. That's very, very famous, right? So Polygon, which is introduced by three Indians, of course, they get enough and more investing from the international investors, angel funding they have received. Yeah. So here, can you select this, the Polygon faucet? No, before going to that, I will explain the simplest method to add a blockchain to the wallet. Yeah, here you can list, you can see numerous blockchains and their associated cryptocurrencies, right? Then if you want to add, then Polygon is actually dealing with the real money. Okay, for example, Polygon, like as I said, this Ethereum mainnet, it will deals with the real money. Polygon is also dealing with the real money, which is Matic. Okay. Polygon is also giving us a test network for developers. We call it as Mumbai testnet. So Mumbai is the test network provided by Polygon, which I hold enough and more money. These are test Matic. This is not original one. Okay. These are all we call it as fake money for the experimental purpose. Yeah. So the next part is that how we can add a new chain to your existing wallet. So for that purpose, I have already introduced you the chain list org. You can add a new existing network two ways, either in a manual way or in an automatically, you can automate that one using the chain link. So I'm saying that Mumbai. Okay, Mumbai. So the simplest way is that just press on the add to MetaMask. What it is asking? It is asking that you can approve it, or if you continue with that, automatically this Mumbai test network will be added to your wallet. Okay. Next is, of course, you have added. Next, we have introduced or we have updated a Mumbai test network or Polygon with our wallet. Is there any money associated with that? No. Right? Here I do have money. But if you introduce that, there is no money. So next task is that. So the next task is that you have to introduce or give money to your wallet. Is it so? So here I want to emphasize there is a problem called Oracle problem with the blockchain, because blockchain cannot, we are saying that blockchain can be used for multiple applications, but blockchain has an Oracle problem. It cannot interact with the outside world. So there is a need of Oracle so that it will pulls data from the outside world and it will be given to the blockchain. Similarly, it will retrieve data from the blockchain, it given to the real world. So for that purpose, we need an Oracle. So normally faucets are being used. Through this purpose or through this Oracle, you can Polygon faucet, you can add Matic coins to your network. Say you just want to copy and paste it over here. Okay, in this case, I cannot add because I have enough and more money with me. Yeah, so now what happened is that you want to confirm the process. So it obviously going to be failed because Polygon is saying that you could hold maximum of 4 Matic coin with you. Okay, but if you consider or if you take care of if you do this process, then it is going to be, you can see that 2 Matic coins will be added to your wallet. Okay, so as I have enough and more Matic coins with me, no more additions are made possible because they have to reserve, even if this is a faucet or even if this is a fake Matic coin, they have to preserve. Okay, so maximum 4 Matic coin could be included as part of a single account. Is it clear? So almost I have covered an introduction about the wallets. Next is I want to give you an overview about the smart contracts, how you can create smart contract, right? So for that purpose, I am using a web-based application called Remix. Can you take the Remix? There is no login for that. So please use this particular link. Yeah. So just type this link. You can directly redirect it to this page. Please use that. How many of you have come across through this particular web page? Yeah. Here, the notepad which I have shared, I come up with a sample program. So here you can see some contracts over here, right? Contracts. You can go for adding a new contract. Here is the new file. You can create it with say what.sol, because you have to learn the language called Solidity. Okay, Solidity, Solidity, which is a which is an object-oriented high-level language in order to develop the smart contract. And it is influenced by C, Python, as well as Java, but it's very simple. You just want to know about the very basics of the programming, especially any of the object-oriented programming language. So .sol is the extension. Then you will create a file. Okay. Next is just paste, which I have shared a piece of code with you. Just paste over there. Okay, so I just give you an overview. This is the comment. Comments are, we are normally using it with double slash, right? So this is the comment, and here SPDS is the license identifier. The particular license identifier we are using is the MIT license, where it will helps you to share this smart contract without any restrictions. If you don't use this particular, even if this is a comment and you don't include in your program, it never going to be going to show any error message, but it will show a warning. Okay. And pragma solti means, pragma is the directive where you can specify your compiler version. So this symbol means this program will execute in any of the compiler higher than 8.0.8.7. Normally you may see 8.7 because it is one of the stable compilers available. Okay. And so this is a very simple storage. Then you can go ahead with, yeah. So this is the compiler. Either you can press over here, yeah, then press over this button, or you can press Ctrl+S for compiling. Next come to the picture. Whatever, this is my smart contract that I have created, right? So first the MIT license, pragma solti, which is the directive. I want to add my compiler version, then the contract name, which is the simple storage. It's just a simple storage where you can see that there are different data types available, like Boolean, uint. Uint means it's the unsigned integer where you can represent whole numbers and positive numbers. If it is you want to represent negative number and the positive number, you can go ahead with the integer. Apart from that, it is also possible to store address. Address means what? Your wallet address, right? As part of this variable. Then you have to come across with address. So address is the data type used to store, which is used for using to store your address, the public key. Okay. Then bytes. So these are the different data types available over here. Then we have read a particular name and it is stored in another file, so that it will be a simple storage function. Okay, it's a simple piece of code. Next is, this is the smart contract I have written. Next, I have to deploy it in the blockchain, right? For that purpose, here you can select any one of the blockchains. This is comes under the Ethereum virtual machine. So I am deploying in Ethereum. So you can see that these are the transactions. In theory part, we have already discussed about the transaction hash, right? So this is the transaction hash. This is the gas utilized. For example, in order to execute this function, some sort of cost is associated with that. So this much gas is being utilized. And yeah, these are the details. Okay, timestamp or this is actually I have deployed in the Ethereum virtual machine. You can also deploy this particular piece of code in your real blockchain with the help of your wallet. Okay, for that purpose, you just select the MetaMask. Now deploy it. Okay. Now you are going to deploy the simple storage smart contract in your Mumbai test network. may take time. So this is the Mumbai polygon scan where you can see what are the transactions you have done so far. Yeah, here you can see, as I said, the transactions are being the part of the blockchain. It is immutable, right? So according to blockchain, even if it is a smart contract, it is acting as a transaction. So, but here you can see this is the contract creation. Okay. So while clicking over here, you can see, yeah. So whatever I have deployed to this polygon, the Mumbai test network, it is successful, and the transaction hash means what? Block hash, which is this one. And so from which account to account? So can you identify this is done by me? No, completely preserving the anonymity to some account, and gas is associated with that. So these are the point. So from this, so what we have discussed is that while if you learn the Solidity programming language, you can write the smart contract, then you can integrate or deploy the smart contract in any of this, either in the test network or the real network. Then the smart contract, the backend will be the blockchain. So whatever if you create an interface like using a React JS or any sort of, like, you are very familiar with the web development, right? So if you create the front end, whatever the data pulling from your application, it will be given, it will be validated through your smart contract, and it will be stored at the backend side where it is the blockchain. So then we call it as, it's a decentralized application. Okay, so using Remix as well, you can integrate your front end. So there are n number of plugins available. Can you share once again? Yeah, so there are multiple plugins available. The front end you can integrate with the Remix platform. Screen share. I think. Okay, so regarding the Remix, here you can integrate Remix. It's a web-based IDE where you can create the smart contract. Once you create the smart contract, you can deploy in any of the blockchain, real blockchains as well. And there's a wonderful IDE where you can integrate with multiple things. As I said, if you want to create a privacy preserving smart contract, then you can, I said, like, it's all about the zero knowledge proofs, right? For the researchers. So here, the Socrates is the tool which we are using. We are using to implement privacy preserving smart contracts. Okay, what's the basic is that for a validator, he don't want to see what's the actual data. Without seeing the data, at the same time he want to validate that transaction as well. So you may yeah, so you may heard about some abstractions, right? In object oriented language, abstractions are there. Like similarly, some sort of abstraction now it's not exactly like abstraction, but we are making it as an abstractive level of data. So we make it as private and the public using the concept of zero knowledge proof. Without revealing the data, you can prove the validity of the transaction. So Socrates is the tool which we want to implement the SNARK program. ZK SNARK means zero knowledge proof. Zero knowledge succinct argument. So zero knowledge proofs can be implemented using this remix platform while integrating it with the plugin called Socrates. That's all. Thank you. If you have any queries, please ask.
Is the blockchain technology not quantum secure?
No, it's not secure. It's not quantum secure because there are multiple reasons. It's not actually, as I said, if it is an adversary, okay. So let me give you some glimpse about the problems, research problems over here. One problem is that the hackers or the crackers or the people who are playing in the cryptanalysis part, where they do not play on the hardened side. They do not play on the cryptographic in order to crack all those things. But they will find out a loophole in this particular system. The loophole here is regarding the MetaMask. The loophole is regarding your wallet, because wallet is the one who store your public key and the private key. Private key is a very attractive thing for the adversaries. So wallet is very vulnerable because wallet, we are saying about cryptography, we are saying about security, backend hashing, everything is that. But what's the security of the wallet? Simple HTTPS with a normal one. It's a two-way. Yeah, maximum it is two-way authenticated one. Okay, maximum we can make it as a two-way authenticated one. That's only security which is enabled as part of the wallet. So my point is, here there are researchers going on to make it as multi-party computation. You may heard about that. The idea is that just remove the concept of storing the private key in your wallet. For that purpose, instead of this private key is being divided into shares, one share is given to you. Similarly, the shares are being given to all the peers who joining to the network. So if a transaction is there and if it is termed to be valid, then the more than 50% of the peers want to agree upon the transaction and they will generate a private key. So that is known as the multi-party threshold computations. So that's the research part over here. You can explore more. Coming back to your question whether it is quantum secure. It's not quantum secure. It's another vulnerability or the weakness when comes to the quantum computers, because of the Shor algorithm and the Grover's algorithm. Especially Shor completely vanishes the public key infrastructure. You can see that in our PPT. We have already discussed that this is the public key infrastructure we are using, right? Here, this is a vulnerable. When it comes to quantum computing or so here we are using an elliptic curve encryption, so which is a public key encryption. It will completely the quantum computers will overcome or will destroy all the public key infrastructure, including RSA or ECC. Okay, so of course it is vulnerable to quantum computers, and your particular answer is that it's not quantum secure. So what will be the solution, right? Instead of this normal encryptions, you can come up with post quantum algorithms. Like in the previous algorithm, in the previous class, you may heard about lattice based, hash based, especially lattice based we heard a lot, right? You can replace with an ECC based algorithm. Instead of ECC algorithm, you can come up with a lattice based algorithm to make it as quantum secure. Okay. Yeah. Any queries from the participants? Yeah.
Ma'am, good afternoon. ma'am.
Good afternoon.
Ma'am, you said earlier when sending when transferring bitcoins from Alice to Bob, uh, we also send a digital signature which consists of public key of A.
Uh, Yeah, transaction, digital signature along with the public key
Public
of
key.
the whoever sending that, like here if it is Alice, then Alice public
Alice.
key. Yeah.
And you also said that it is known to every other peer in the blockchain. So how does every peer know that? Like I know B knows because we are
It's a
transferring.
neighbor, right? It's a
Yeah,
neighbor.
transferring.
Eventually, for example,
Is it
the
through
flooding,
ledger?
yeah, that's the concept is in such a way that yeah, the concept is the flooding concept is in such a way where yeah, I will explain that. So if a particular node initiate a transaction, it will flood only towards its neighbors. It can flood only towards neighbors. So if B is a neighbor, then B will receive the transaction. Once B receives the transaction, what happens is that he will check for the validity of the transaction first. Then origin also he will check. After, if all the validations is correct, then B will again broadcast that transaction so that it will reaches to his own neighbors. Ultimately, it as it is a peer-to-peer network, it reaches all the peers in the network. Yeah, that's a concept used.
Like before transaction, does every peer know?
Before, I don't get you. You know?
Like public key of A. Is
No,
it
no,
known?
no, 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 no.
Only
Because
and
yeah, because this peers in the network is anonymous, and moreover, for example, this is a very autonomous network or heterogeneous network in such a way that I can get into the network without any permission. Similarly, I can get out of this network without, it's a permissionless network. Anybody can get into and get out. So in such a way that when I initiate a transaction, then only along with that transaction, my public key is being sent.
so it's only after the transaction is validated, every other node will know the public key.
No, no. Suppose I have initiated a transaction, okay? Then I have sent to some other person. So transaction plus my public key plus the signature of the transaction I am broadcasting to everyone. Then the receiving party will receive what? Transaction, my public key, as well as the digital signature.
What about the other nodes then?
If then if the nodes are a neighbor to that particular initiator who initiates the transaction, of course it will receive. Otherwise, they have to wait. Maybe in and around the scenario is that within 10 minutes, that transaction will be received by all the rounds in the network. 10 minutes on an average, 10 to 15 minutes.
Is it through ledger maintain?
Ledger means the transaction is stored in the ledger. Yeah.
Thank you.
Yeah. Thank you. Any queries?
Good afternoon, ma'am.
Good afternoon.
Ma'am, my question is like how the gas price has been determined for a transaction. Like,
Yeah. Gas prices depends upon the complexity of the function that is written inside the smart contract. See, for example, here I have a voting application. Then I have, yeah, so fund me application. Okay. I will just take. Okay, so fund me application or voting application, I could say rather. Yeah, so it is compiled. Then I am just deploying to the Ethereum virtual machine. Here you can see the output, where you can see the output in that. So once you deploy it in any of the blockchains, you can see the output. Can you see this output? Storage and the favorite number. Favorite number, both are buttons, but storage is a function. If you execute this function, it will utilize more gas than this favorite number. So it's completely depends upon the function that you incorporate in your smart contract. Yeah. So if it is a, just assume that if it is a smart contract that could hold money, okay, then this instead of this orange button, there will be red button. Okay, that's a function which could hold money. So that will cost more than a normal function. So it's completely depends upon your function, how much gas is costing. Yeah.
And ma'am, like there is a way and GUI involved in that gas transactions, price. What is that exactly?
Great. Yeah. So here you can represent the money in terms of either or gas is very, very low cost one, right? We can say that it's a nano ether. Okay. So there should be a representation unit to represent that nano ether, that is GUI, way, etc. Yeah.
Thank you, ma'am.
Thank you. Online on. Yes. Yeah, I have already answered that. The blockchain technology is quantum secure, it's not quantum secure. You can make it quantum secure by enabling the post-quantum techniques in the blockchain. Thank you all. Thank you for your patient listening.
Thank you, ma'am, for this descriptive session and for sparing time from your busy schedule to be here today.